All right, so before we get started, I just want to point out a couple key features of trig graphs. Now, this right here is the format of the equation for any sine or cosine curve that we're going to be working with in this packet. So the number in front of the word sine is your amplitude, and the number in front of the x is your frequency. Okay, so we'll keep that in mind with a lot of the questions we're going to be doing here. All right, these two formulas right here are just two formulas that'll help you out throughout the packet. So period is equal to 2 pi divided by frequency, just as frequency is equal to 2 pi divided by period. Okay, so we'll keep that in mind. All right, now, the first couple questions, the ones on this page, they just want us to pick out which equation is shown in the following graph. So if we look at the picture in number 1, this graph right here, we could see the amplitude is 0.5. So since amplitude is the number that goes in front of the word sine or cosine, we're going to need to pick out which ones have an amplitude of 1/2. So letter A and letter C do. So I can automatically eliminate letter B and D because they don't have the right amplitude. Okay, now, the frequency is the number that we put in front of the x. The frequency is the number of complete curves between 0 and 2 pi. Okay, now if we look at this graph here, we could see that between 0 and pi, we're fitting one complete cosine curve. So if we went all the way to 2 pi, we would fit another entire cosine curve. So here the frequency is 2 because between 0 and 2 pi, we're fitting 2 complete cosine curves. So this, letter A, is the one that shows a frequency of 2. So letter A is our answer. Okay, number 2. So in this graph, now if you look at the answer choices, they have sine and cosine. So basically, for our purposes with this intro to trig graphs, if our curve does not go through the point 0, 0, then it's not going to be sine, right? Our sine curves go through the point 0, 0. So this is not sine. So I'm going to automatically eliminate choice A and C because those are sine curves. So now this has got to be a cosine curve. Now we could see, since this is starting up here at positive 2, right? It's going to drop down. It would continue on, come back up to 2. But here the amplitude is 2. So since this one shows an amplitude of 2, and this one has an amplitude of 1/2, it's got to be this right here, letter B. Okay, so I'm not even going to look at the frequency. It doesn't matter because we can automatically eliminate choice D as well. Okay, if you did want to just make sure here the frequency is 1/2, that means between 0 and 2 pi, we'd be seeing half of a cycle. So this is 0 to pi. Figure if we made it to 2 pi, it would continue all the way down to -2, which from here to here is a half a cosine cycle, half a cosine curve. So this one does match up. Okay, so number 3. Which equation represents the graph below? Okay, so let me first eliminate based on whether it's a sine or a cosine curve. So again, it's not going through the point 0, 0. So it's not sine. So I'm going to eliminate letter A and B. All right, now let's look at the difference with these. They both show that it's a negative cosine curve, which is true because it's starting down low. And it has an amplitude of 2, which is true because the height is 2. But this one, letter C says the frequency is 2, and letter D says the frequency is 1/2. Now the frequency is the number of complete cycles between 0 and 2 pi. So we could see we have 2 complete cycles. So the frequency is 2, so it's got to be letter C. Okay, and then letter D, again, this is a cosine curve, right? It's not going through the point 0, 0. So I'm going to eliminate, in number 4, letter B and D because those are sine equations. Now, if we look at A and C, they both have an amplitude of 2, which is true. And then here it's saying the frequency is 3, whereas here it's saying the frequency is 2 pi divided by 3. Now, these might be a little confusing to think about. So I think what I'm going to do instead, we know a formula for frequency, right? Right up here. The frequency is equal to 2 pi over the period. So let's maybe do it like that. The frequency equals 2 pi over the period. Well, let's think about what period means. Period means the horizontal length of one complete cycle. So this is one complete cosine cycle, and horizontally, it took 2 pi over 3 units to get there. So the period is 2 pi over 3. Okay, so now whenever we have division and there's a fraction involved, we could do keep, change, flip. So we're going to keep the numerator. We're going to change this division to multiplication. And we're going to flip this fraction upside down. So now it'll say 3 over 2 pi. Okay, if you want to put this over 1, just so you have a fraction times a fraction, that's fine. Now what's going to happen is this 2 pi on top is going to cancel with this 2 pi on bottom. So really all we're left with is 3 over 1, which simplifies to 3. So the frequency is 3, so letter A is our answer. Okay, number 5 asks us to determine the period of the equation. So if we look over here, right, we know period is equal to 2 pi over the frequency. So if we take 2 pi and divide it by, well, the frequency is the number in front of the x, right? So here the frequency is 2. So if we take 2 pi and divide it by 2, that's going to leave us with pi. So our period is pi, which is letter C. Okay, so number 6 is asking the same thing, right? They want us to find the period. So again, period is equal to 2 pi over the frequency. And in this case, the frequency is 6, right? The number in front of the x. All right, well, since 2 over 6 simplifies to 1 over 3, this would be 1 pi over 3, which just is pi over 3. So that is letter B. Okay, so number 7 wants to know how many full cycles would appear in 2 pi radians if we were to graph this function. Okay, so the frequency is what's going to help us out with that. So here you could see the frequency equals 2. Now, we know the frequency, right, is the number of complete cycles between 0 and 2 pi. And that's what this question is asking us, how many full cycles would appear in 2 pi radians. So how many full cycles would appear between 0 and 2 pi? Well, the answer is 2, because that's exactly what the frequency is. Okay, now number 8 asks the same thing, except they want to know how many full cycles of that same exact function would appear in pi radians. Okay, so since the frequency is 2, that means we would see 2 cycles within 2 pi units. So if we were just looking at 1 pi, we would only see 1 cycle. So letter A, 1, is the answer. Okay, we would see 1 cycle between 0 and pi, and another cycle between pi and 2 pi. Okay, number 9, which equation represents a graph that has a period of 4 pi? All right, well, for this one, I'm going to just use my period formula, right? Right here again. So period equals 2 pi over frequency. Okay, so I'm just going to, I guess, go through the answer choices one by one and see what works. So when we do this first one, right? The period is equal to 2 pi over, well, our frequency is the number in front of the x, which is 1/2. All right, so a lot of you guys I know have this one memorized, right? We know that 2 divided by 1/2 is 4. So this would be 4 pi. If you don't have that memorized, that's fine. 2, you could do keep, change, flip. Okay, so you could keep the 2 pi. Whenever you're dividing with a fraction above, you do keep, change, flip. We're going to change the division to multiplication. And if you flip this upside down, it's 2 over 1. Okay, so 2 pi times 2 over 1 would be 4 pi over 1, which is just 4 pi. And actually, that's the answer, right? Because they wanted to know which one has a period of 4 pi. So letter A is the answer. If you went through all the other answer choices, you would see, you know, plug these into the formula, you would see none of these would be equal to 4 pi. Number 10 and number 11 both want to know what is the amplitude of the given function. So if you look over here, the amplitude is just the number that's in front of the word sine or cosine. So in this case, the number in front of the word sine is 1/2. So that is the amplitude. And in this one, the number in front of the word sine is 3. So there's our amplitude. So letter C. Okay, number 12. They want to know the period of the function. So whenever we see the period, we're going to use this formula right here. Period equals 2 pi divided by frequency. So if I do 2 pi divided by, well, we know the frequency is the number that's in front of the x. So here there's a 2 in front of the x. So I'm going to take the 2 pi and divide it by 2. So these 2's cancel off, leaving us with just pi. So letter C is our answer. All right, number 13, they want to know what is the amplitude. Well, we could see right here, it's going to a height of 2. So 2 is going to be our amplitude. Oop. All right, number 14, they just want to know which graph is shown here. Now, first of all, you can see it's going through the point 0, 0. So we know this is going to be a sine curve. So I'm going to eliminate B as well as D because those are cosine curves. Now, the only difference between choice A and choice C is choice A has a frequency of 1, which means you would fit exactly one sine curve between 0 and 2 pi, or in any span of 2 pi units. And letter C has a frequency of half, which means you're only fitting half of a sine curve between 0 and 2 pi. Now, if you look here, this is 0 and this is pi. Okay, we're fitting half of a sine curve between 0 and pi. But if we went all the way to 2 pi, wouldn't we fit the entire curve, right? From 0 to pi, we're fitting half of the curve. And if we continued on to 2 pi, we would fit one whole sine curve. So the frequency is 1. So letter A is the answer. All right, number 15. So they want to know, as angle x increases from pi over 2 to pi, what happens to the value of sine of x? So what I did was I just graphed y equals sine of x right here. So as x increases from pi over 2 to pi, what's happening is, look, at pi over 2, it's at a height of 1. And then it's going down to a height of 0 as it approaches pi. So it's going down from 1 to 0, which is letter D. All right, so in number 16, they tell us the period is 1/3, and they want us to find the frequency. Okay, so I'm going to use this formula. Frequency equals 2 pi divided by the period. Okay, so the frequency is equal to 2 pi divided by, and they tell us here the period is 1/3. Okay, so now when we're dividing with a fraction involved, you're going to do keep, change, flip. So we're going to keep the 2 pi. We're going to change the division to multiplication. And we're going to flip this fraction upside down, so 3 over 1. Basically what we're doing is we're multiplying by the reciprocal. All right, so if you want to put this 2 pi over 1, you can. So 2 pi times 3 is 6, so we have 6 pi over 1, which is just 6 pi. So letter B is our answer. Now, the next one, number 17, asks you for the same thing. They want you to find the frequency if they give you the period. So I'm going to use frequency equals 2 pi divided by period. Okay, so let's do the same thing. Let's keep. Change the division to multiplication, and flip this upside down. So I'm going to make it 2 over 3 pi. Okay, and if you want to put this 2 pi over 1, you can. Now what happens is this pi on top cancels with this pi on bottom, and then if you multiply across, 2 times 2 is 4, and then 1 times 3 is 3. So you get 4 over 3, which it looks like is letter D. All right, let's see what else we have here. So number 18, which equation is represented by the accompanying graph? Okay, so first, I wanted, you could tell it's not a sine curve because it doesn't go through the point 0, 0, but that doesn't even help us eliminate anything because everything is cosine. Okay, so now let's look. The amplitude is 1, right? So we can eliminate at least letter D from that. That one shows an amplitude of 1/2. So now we have to decide what is the frequency. Is the frequency 1, 1/2, or 2? So the frequency is the number of curves that fits between 0 and 2 pi. So between 0 and pi, we could see we have the first half of a cosine curve. But if this continued on to 2 pi, we would have the second half of that. So really, between 0 and 2 pi, we're fitting one complete cosine curve. So the frequency is 1. So that is letter A, because there's technically a 1 in front of that x. Okay, and then number 19, what is the period of the graph? Okay, so they give us an equation. Now, I'm going to use this formula right here. So the period is equal to 2 pi over the frequency. So you could tell the frequency in an equation by whatever's in front of the x. So here the frequency is 1/3. All right, so since we have division and there's a fraction involved, we could do keep, change to multiplication, flip upside down. Okay, so keep, change, flip. And so that leaves us with 2 pi times 3 is 6 pi, and then over 1, which is just 6 pi. I think we just had that question up above on the page as well. All right, so that was kind of a repeat. So this one is letter C. Okay, so number 20 asks us to come up with the equation of this radio wave, so of this function right here. Now, first of all, we know it's a sine curve because it goes through 0, 0, which doesn't help us out because these are all sine. Now, the amplitude is 1.5. Okay, that's the height it's going up to. Actually, so if you look, letter B is the only one that has an amplitude of 1.5. A and C have amplitudes of 1, because that's the number in front of the word sine. And letter D has an amplitude of 2, because that's the number in front of the word sine. So letter B has to be the answer. But I just want to kind of finish up with this equation. Now here it's saying the frequency is 1. So that means between 0 and 2 pi, we're fitting one complete sine curve. So if you think about this, between 0 and pi, we're fitting half of the sine curve. If we kept going to 2 pi, we would fit the other half. So we would fit one complete cycle between 0 and 2 pi. All right, so in 21, they want to know which statements are true. So the first one says the domain. Now, we know the domain just refers to the x values. So let me just put that. The x values. Okay, so the domain is all real numbers. Well, that's true. The domain, the x values, I mean, this graph could keep going and going and going to the left. And as you work your way to the right, it could keep going and going and also. So the x values, there's no limit. You can use anything within the x-axis. So that is true. Okay, here it says the range. Y is in between -1 and +1. And because these are underlined, -1 and +1 are included. Okay, so this is saying that y is greater than or equal to -1, but y is less than or equal to +1. That's true. It's saying that the range, the y values fluctuate anywhere from -1 to +1, and that's true. Okay, now the period. We know the definition of the period is the length of one complete cycle. So this is saying the length of one complete cycle is 2 pi units. Well, that's also true. It takes 2 pi units to complete one cosine curve. So that's true as well. So everything is true. So letter D is our answer. Okay, in 22, they want us to figure out which one has an amplitude of 2. So first of all, A and B have amplitudes of 2. C and D don't. They have amplitudes of 4, right? The amplitude is what comes in front of the word sine or cosine. So I'm going to cross off letters C and D. Okay, and then it says a period of 4 pi. Okay, I mean, technically you can use either one of these two formulas, but I'm going to use the bottom one. If they tell us the period, I might as well just plug that in where it says period. All right. So I'm going to do frequency equals 2 pi divided by the period. And again, they tell us the period, right? They say the period is 4 pi. So let's divide this by 4 pi. And then what happens is the pi on top cancels with the pi on bottom, and 2/4 simplifies to 1/2. So that tells us our frequency has to be 1/2. So that's letter A, okay? The frequency is in front of the x, and that's equal to 1/2. Okay, 23 just wants to know what is the period of the graph of this equation. All right, well, we know that period is 2 pi over frequency. So since the frequency is B, it's going to be 2 pi over B. And this one, I mean, this says 2 pi over the absolute value of B. That's technically correct because it has to be a positive number. The frequency, you know, how many times that happen has to be a positive number. So letter B is the correct answer. Okay, so in number 24, they want to know which graph represents the reflection of y equals cosine of x in the y-axis. Okay, so what I did here was I graphed y equals cosine of x. Now, I graphed it from -2 pi to +2 pi because that's what they did in all of the answer choices here. Now, if you're going to reflect over the y-axis, so over this line right here, it's basically like taking your graph and folding it along the y-axis. Wouldn't this graph, if you fold it along the y-axis, fit directly on top of this half of the graph, right? This portion, folded along the y-axis, would land right exactly here. So, and this portion, if you fold it, would land right exactly here. So it would look exactly the same. So letter B, the second one, is the one that looks exactly the same. All right, I'm going to try to leave this graph in here. Well, okay, I might have to scroll up a little bit, but they want to know if we were to reflect in the x-axis, what would it look like? So this time we're folding along this axis right here. Well, when you reflect in the x-axis, isn't that the same as just putting a negative in front of it, right? It's like graphing negative cosine of x. Or think about it. If you reflect in the x-axis, wouldn't any maximum point, anything that's at positive 1, come down to negative 1, right? All these ones at positive 1 would fold over to negative 1. And see these points that are at negative 1? Wouldn't they fold over the x-axis and wind up here at positive 1? So basically, your graph would look like this, okay? So let's see which answer choice shows that. Okay, this one right, oop, sorry about that. This one right here shows it, letter C, okay? We have basically y equals negative cosine of x. Okay, so letter C is the answer. Okay, so in 26 through, I'm just looking here, 37, they want you to write in a trig equation for each of the following functions. Now, remember, whenever you go to write an equation, there's 3 things I want you to think about. Okay, first of all, I want you to think about whether this is a positive or negative sine curve or a positive or negative cosine curve. Now, we know it's a sine curve, right, because it goes through 0, 0. And if you start at 0, 0, the graph starts off going up. So what we can say so far is that it's a positive sine curve. Okay, the next thing I want you to think about is the amplitude. Well, here it's going up to a height of 1. So we can say that our amplitude equals 1. And then the frequency is the number of complete cycles between 0 and 2 pi. So we're fitting one complete sine curve between 0 and 2 pi, so the frequency would be 1. All right, so if we want to make our equation, it's just y equals positive 1 sine, so positive sine of 1x, so just x. You don't have to actually put the ones in there, so y equals sine of x. Okay, so now in number 27, this is again a sine curve, right? Because it's going through 0, 0. But if you start at 0, 0, since it's going down first, it's going to be a negative sine curve. All right, so that's the first thing I want you to list out, negative sine curve. Okay, now, here our amplitude, even though it's going down first, our amplitude itself is still 4. The amplitude is the height of the curve. You could never have a negative amplitude, so the amplitude is positive 4. Okay, now the frequency is the number of complete curves between 0 and 2 pi. So we're fitting one complete negative sine curve between 0 and 2 pi. So the frequency is 1. So now when we go to write our equation, we have a negative sine curve. So it's going to be y equals negative, and we put the amplitude in front of the word sine, so negative 4 sine of 1x. The frequency is 1. Okay? All right, number 28. Okay, so when we look at this one doesn't go through the point 0, 0. So this one is going to be a cosine curve. And because it's starting off high and then dropping down low before it comes back up, a positive cosine curve starts high. Okay, so we have a positive cosine curve. All right, now the amplitude of this is, just look for the highest point here, is 3. Okay, so our amplitude equals 3. Now the frequency is a little harder. The frequency is the number of complete curves between 0 and 2 pi. Now, you could do this one of 2 ways. You can either look and say, well, look, here's 0 and here's pi, right? They label a lot more on this x-axis, but here's 0 and here's pi. So I'm fitting 1, 2 cycles between 0 and pi. So if I were to go all the way to 2 pi, I could fit twice as many cycles. I could fit 4 cycles. So my frequency is 4. Now, if you had trouble doing that, keep in mind we have a formula that we could always use to find the frequency. We know that frequency is equal to 2 pi over the period. So here, if you look, the period is the length of one cycle. So the period, one cycle goes from here to here. So it takes pi over 2 units to do that. So pi over 2, right, is your period. So you could replace period with pi over 2. And then you could just do keep change flip. So I'm going to keep the 2 pi, I'm going to change division to multiplication, and I'm going to flip the pi over 2 upside down. So it's now 2 over pi. Okay, so if I want to multiply these, I could put this over 1, and what happens is this pi on top cancels with this pi on bottom, and 2 times 2 is 4. So either way, we get our frequency to be 4. Okay, so then if we want to write our equation, right, we have a positive cosine curve whose amplitude is 3 and frequency is 4. So basically, we're going to have we always put the amplitude in front of the word sine or cosine, and we put the frequency in front of the x. So we have y equals 3 cosine of 4x. And you don't need these parentheses, but if you prefer to put them, that's fine too. Either way is okay. Okay, so we can see here in number 29 that this is a sine curve because it's going through 0, 0, and it's a positive sine curve because it's starting off going up and then down. Okay, so we have a positive sine curve. Okay, so now the amplitude is 4. Okay, that's the maximum height it's reaching right now, so the amplitude is 4. Now the frequency you could do one of two ways. Some of you might look and say, oh look, here's 2 pi. So we're only fitting, like, to go up, to go from here to here is only 1/4 of a sine curve. Because think about it. If you made it to here, you'd be halfway through. If you made it to here, you'd be 3/4 of the way through. And if you made it to here, you'd be all the way through one cycle. If this is one full cycle of a sine curve, from here to here, which is where 2 pi is only 1/4 of it. So the frequency is 1/4. Now, if that was hard for you to see, that's okay. That's why we have formulas, right? The frequency we know is equal to 2 pi divided by the period. So the period is how long it takes to complete one cycle. So it takes, here's one full cycle, okay? That ends at 8 pi. So 8 pi would be the period. So if you simplify 2 pi over 8 pi, the pi's cancel, and 2 over 8 simplifies to 1/4. So either way, we get the frequency to be equal to 1/4. Okay, so then we just have to write our equation. And when you write the equation, please do not forget this part, y equals. Without the y equals, it's not an equation. Okay, so the amplitude's 4, and it's a positive sine curve, so 4 sine, and the frequency is 1/4, so 1/4 x. So y equals 4 sine 1/4 x. And again, you do not need these parentheses, but if you like them, you could put them. Okay, so now in number 30, we could see, okay, it's not going through 0, 0, so it's not a sine curve, so this is a cosine curve. Now, on the y-axis, it's starting low instead of high, so that means this is a negative cosine curve. Okay, it's kind of like an upside-down cosine curve. So here we have a negative cosine curve. All right, now, they didn't number the axes, but if they don't, right, it's implied that each box represents 1. So this would be 1, 2, 3. So the amplitude is 3. And the frequency, the number of complete cycles between 0 and 2 pi. Well, this from here to here is one complete cycle, and that's between 0 and 2 pi. So the frequency is 1. We're fitting one cycle between 0 and 2 pi. So if we wanted to write our equation, the amplitude is 3, but it's a negative cosine curve. So we would write y equals negative 3 cosine of just x, right? If you want to put the 1 in front of the x, you can, but usually if it's a 1, we don't. So y equals negative 3 cosine of x. Okay, so in number 31, now if we look here, we have a cosine curve, right? It's not going through the point 0, 0, so we know it's not sine. And because it's starting low, just like the last one, and then coming up, we know it's going to be a negative cosine curve. All right, so there we go. Now, the amplitude is, here's a 2, here's a 4, it's right in the middle of that, so the amplitude is at 3. And then the frequency, now the frequency here, because our axis is not numbered in terms of pi, we're gonna wanna use our formula, frequency equals 2 pi over the period. Now, in order to use that formula, we have to know what the period is. So if you remember, the period is the horizontal length of one complete cycle. So from here to here is one complete cycle, and if you look up, it takes us 1 unit to do that. So if we use frequency equals 2 pi over the period, we're going to do frequency equals 2 pi over 1, because 1 is the period. That's how long it takes us to complete one cycle. And then 2 pi over 1 just simplifies to 2 pi. Okay, so from here, we can just write out our equation, right? We have a negative cosine curve. The amplitude is 3, and the frequency is 2 pi. And don't forget the x. You want to have 2 pi x, okay? Okay, so in number 32, so we could see here that this is a cosine curve, right? We know it's not sine because it would go through 0, 0. So since it's starting off high, we could say it's a positive cosine curve. Okay, now we could see here our amplitude is 5. And the frequency, I mean, again, with this one, because the x-axis isn't in terms of pi, I'm going to use that formula, frequency equals 2 pi over period. Now let's think about what the period is. The period is how long it takes to finish one cycle. So here's one cycle, and you can see along the x-axis it takes 4 units to get there. So again, frequency is equal to 2 pi over the period, which is 4. So frequency is going to be 2 pi over 4. All right, and then since 2 over 4 simplifies to 1/2, this would be 1 pi over 2, which is just pi over 2. And then we could write out our equation. So y equals positive 5 cosine of pi over 2x. And don't forget the x. A lot of times people forget the x, I realize. I see. So don't forget about the x here. Okay, so number 33. Now, this one is a sine curve because, look, it's going through 0, 0. And because it's going up first, it's a positive sine curve. Okay, now the next thing, the amplitude is 2. Okay, and then the frequency. Now, we know the frequency is the number of complete cycles between 0 and 2 pi. So let's count these out. So we have 1 cycle, 2 cycles, 3 cycles, and 4 cycles. So we're fitting 4 complete cycles between 0 and 2 pi. So the frequency would be 4. Okay, so then we could just write out our equation. Y equals positive 2 sine of 4x. All right, number 34. So we could see here this is a cosine curve, right? We know it's not sine because it's not going through 0, 0. Now, not only is this a cosine curve, but on the y-axis, it's starting low and then coming up. So it's an upside down cosine curve. So that tells us that we have a negative cosine curve. Okay, don't think about the starting point is over here just because this is high. You want to look where it starts on the y-axis. On the y-axis, it's starting low and then coming up. Okay, the amplitude is 4, right? That's the height that it's reaching here. So the amplitude is 4. And then the frequency. Now, the frequency, again, because the x-axis is in terms of numbers, just like some of the other ones we did, we're going to use our formula. Frequency equals 2 pi over the period. So the period is how long it takes to complete one cycle. So if we look from here to here, right, starting here and ending here, this is where the cosine curve would end. This is one complete cycle. So if you look at the x-axis, it took us 2 units to get there. Okay, so the period is 2. That's how long it takes us to complete one cycle. So since the period is 2, if we say frequency equals 2 pi over period, frequency would be 2 pi over 2. And then the 2's would cancel, leaving us with pi. So then we could just write out our equation. And don't forget the y equals with your equation. Y equals negative 4 cosine of pi x. All right, so number 35 is a sine curve, right? We see 0, 0. And not only is it a sine curve, but it's a positive sine curve. It's going up first, right? So we have a positive sine curve. Now the amplitude is, sorry about that. The amplitude is 5. Okay, so let me uncover that. Now, the frequency, this one is a little tricky because even though it's numbered in terms of pi, we're not used to having these numbers. This is the only one that looks familiar to me. And it looks like we're fitting like 3/4 of a sine curve between 0 and pi over 2. So it might be hard to figure out how many you're fitting between 0 and 2 pi. You could keep going and draw it out and see. But personally, I think the easier way to do this one is to use our formula for frequency. So we know that the frequency is equal to 2 pi over the period. So the period, let's see, the period is how long it takes to complete one cycle. So this is one cycle, and this is at 2 pi over 3. So the period is 2 pi over 3. Okay, now, because we're doing division and there's a fraction involved, we're going to do keep, change, flip. Okay, so we're going to keep the 2 pi, we're going to change division and multiplication, and we're going to flip so that we have 3 over 2 pi. Okay, this actually isn't bad because what happens is the 2 pi on top cancels with the 2 pi on bottom, and it leaves us with a frequency of 3. All right, so, this whole thing's moving down. Okay, that's okay though. All right, let me just keep going. So we're going to have y equals positive 5 sine of 3x. Okay, that's our equation for this. Y equals 5 sine of 3x. Okay, so in number 36, we have a cosine curve. Okay, again, it's not sine because it's not going through 0, 0. And it's a positive cosine curve because on the y-axis, we're starting high instead of low. All right, so we have a positive cosine curve. The amplitude is 6. And the frequency, we're going to have to use our formula. Frequency equals 2 pi divided by the period. Now, don't be tricked. Don't think the period is 3 because they're showing us up until 3. The period is how long it takes to complete one cycle. So from here to here is one complete cycle. This is where our cycle ends. So if you look down, that happens at 2 units. It takes 2 units to finish our cycle. So the period equals 2. Okay, so frequency equals 2 pi divided by period. So 2 pi divided by 2. And then these 2's cancel off, leaving us with just pi. So now when we write our equation, we have y equals 6, positive 6, cosine of pi x. All right, and then number 37. 37 is a sine curve. It goes to the point 0, 0. And since it's going up, it's a positive sine curve. Okay, the amplitude is 4. And the frequency, so the frequency is the number of complete cycles between 0 and 2 pi. So this one might be a little tricky to look at because it's like here's one cycle, right? It ends at 3 pi over 2. So like how far into it are we going when we get to 2 pi? I'm going to do this a little different. I'm going to use our formula. Frequency equals 2 pi divided by the period. Okay, so the period, since it takes 3 pi over 2 units to end that cycle, right? This is where the cycle ends. I'm going to plug in 3 pi over 2 for our period. Okay, and then we'll just do keep, change division to multiplication, and flip that fraction in the denominator upside down. Okay, this pi on top cancels with this pi on bottom, and when we multiply this out, 2 times 2 is 4, and 1 times 3 is 3, so we get 4/3. So our frequency is 4/3. Okay, so now we could just write our equation. So the equation would be y equals positive 4 sine of 4/3 x. All right, now for the hard ones where we actually have to graph them by hand. So the first thing they want us to do is determine the amplitude, frequency, and period. So the amplitude is in front of the word sine or cosine, so in this case it's 2. The frequency is in front of the x, so in this case it's 1/2. And the period is 2 pi divided by the frequency. So since the frequency is 1/2, it's 2 pi divided by 1/2. Okay, which at this point we should all know is equal to 4 pi, but if you have to do keep, change, flip, you can do that as well. Okay, so when we multiply across, you get 4 pi over 1, which is just 4 pi. All right, so let's think about this. So we have a cosine curve. Now, whether you're graphing sine or cosine, a full cycle of each of them has 5 points, right? A cosine starts high, ends high, halfway between them, we're at its low point, its minimum, and halfway between any maximum and minimum, you're going to be on the midline, which in this case is the x-axis. So same thing halfway between a minimum and a maximum, you're going to be at its middle height, its midline, which is the x-axis. So the cosine curve curves like that. Okay, so now let's just say, if our frequency is 1/2, what that means is we're only fitting half of this between 0 and 2 pi. So what I'm going to do is I'm going to erase the half that we don't need, and this is what we're going to be graphing, right, between 0 and 2 pi. So this point, the high point, is going to be at when x is 0. So when x is 0, we're going to be up here at a maximum of 2. Okay, so we plotted this point already. Okay, now let's plot this low point. So this, we're going to have to go all the way over to 2 pi, and that's where we're going to be at the minimum. Now let me explain why again. Okay. So since the frequency is 1/2, it means we're only fitting, this is a really bad cosine curve, but we're only fitting half of a cosine curve between 0 and 2 pi. So at 0, we graphed that first point, which was up at a maximum. At 2 pi, we're going to have to graph that last point that we see here, which is at a minimum. Okay, so at 2 pi, I'm going to go all the way over to 2 pi and go down to its minimum, which is at -2. Okay, so I plotted this point now too. So now I just have to plot this point in the middle of them. So halfway between 0 and 2 pi is pi. And at pi, we're going to be at it on the midline. We're going to be on the x-axis, okay? Because we're at the middle height between the maximum and the minimum. So we're going to be right here on the x-axis. And then when you curve it, this is a really bad drawing. Sorry about that. You want to just make it, cosine curve is just going to kind of like flare down and out and over, okay? It just has to be curvy. So that's what our curve looks like. And you always need to make sure that you label the equation, okay? If you don't label an equation on the graph, that's points off. So make sure you do that. Okay, number 39. So our amplitude is 1/2, and the frequency is 2. Now the period is 2 pi divided by the frequency. So since the frequency is 2, I'm just going to plug that into the denominator. And then these 2's cancel, leaving us with a period of pi. Okay, so now I numbered my axes, right? And I did it according to, they told us to go from negative 2 pi to positive 2 pi. And then my amplitude is 1/2. Now I didn't put 1/2 on there, but I put a 1 on there. So we know half would be 1 box up instead of 2 boxes up. Okay, so we need to first of all we're graphing sine. So basically a sine curve, right? Starts at its middle height, ends at its middle height, and halfway between those first and fifth points, we're at its middle height again. Now halfway between these 2 points, sine is going to be up at a maximum. And then halfway between these 2 points, sine is going to be down at a minimum. So the sine curve is going to look something like that. All right, so now let's look at what we had. It says the frequency is 2. So what that means is between 0 and 2 pi, we're going to fit 2 of these. So if we have to fit 2 of these between 0 and 2 pi, that means we have to fit one of them between 0 and pi. And guys, that's why the period is pi. The period tells you how long it takes to complete one cycle. So we have to fit one of these between 0 and pi. So since sine starts on the midline, the middle height, and ends on the midline, the middle height, the first thing I'm going to do is I'm going to put the starting point of our cycle at 0, 0, and the ending point of our cycle at pi 0. Okay, remember, we're fitting one cycle between 0 and pi. And halfway between the first and the fifth point, we're again on the x-axis. So I'm going to put a point right here. Okay, we know halfway between these 2 points, we're going to be at a maximum, which in this case is 1/2. So I'm going to go up to 1/2 and put a point. And then halfway between these 2 points, we're going to be at a minimum, which is negative 1/2. Oops, sorry, I thought I chose the pen. So this is really our first cycle. Like if you want to connect it now, you can. Now, that same thing is going to repeat itself over here. Okay, so from here, if you want to just kind of like, here's the start of our cycle, here's the end of our cycle, halfway between them, we're on the x-axis. Halfway between these 2 points, we're going to be up at a maximum. And halfway between these 2 points, we're going to be down at the minimum. Now, some people like to just follow the trend. Like, basically, you're just kind of going, So if you wanted to, you'd realize the next point would be here, the next one would be there, the next one would be here, and so on. Okay, now as you work in the negative direction, basically, ready? If you start here and start flowing through, what's going to happen is if we go in the negative direction, this is going to come down to negative 1/2, and then up to a height of 0, up to a height of 1, back down to 0. It's just going to keep following the same trend, right? So it's going to go like this. And you could just keep going down to a height of negative 1, up to 0, up to a height of 1, and back down to a height of 0. So it's going to just continue on like that. Okay, so this is y equals 1/2 sine of 2x. Okay, so in number 40, the first thing we have to find is the amplitude. Now, technically, even though there's a negative 1 in front of the word cosine, amplitude always has to be positive. So the amplitude is going to be equal to positive 1. Okay, that negative just tells us that basically the cosine curve is reflected over the x-axis. Okay, our frequency is 2. And then since period is equal to 2 pi over the frequency, 2 pi divided by 2 simplifies to pi. Okay. All right, so again, this negative tells us that our cosine curve is going to start low, come up high, and end off low. Okay, so since our frequency is 2, we're going to be fitting not just one, but 2 of these between 0 and 2 pi. So if we could fit 2 of these between 0 and 2 pi, it means we're going to fit one of them between 0 and pi. And that's why our period is pi. The period is the length of one cycle, the horizontal length of one cycle. So it takes us pi units to finish one of these cosine curves. Okay, so remember, we have 5 points, right? The first point and the last point, as well as that point right in the middle, and the 2 points that are on the midline. Okay, so let's start with our first point and our 5th point. So the first point, the point that goes on the y-axis, we could see this is starting off low. So it's starting off at the minimum, which in this case is -1. So let's put a point at -1. Okay, so since we're going to finish our first cycle when we reach pi, the end of the cycle is also at a minimum. So at pi, we're going to go down to -1 and put the point. Now, halfway between your two minimums, so right there, you're going to be all the way up at a maximum. Okay, so there's 1, 2, 3, 4 boxes between my two minimums. So half of 4 is 2. So 2 boxes over from each of these, we're going to be all the way up here at our maximum, which is at a height of +1. Okay, so at pi over 2, we're going to be at a height of +1. Now halfway between any minimum and maximum, we're going to be on that midline, which is on the x-axis. So basically, you're just going to, since there's 2 boxes in between this minimum and this maximum, we're just going to go over 1 box, and that's where we're going to be on the midline or on the x-axis. Okay, and same thing, if we go from here, just 1 box over, that's when we're going to be on the x-axis. Okay, these points are huge, but, all right, so this is our first cosine curve. And make sure you make it curvy. And then you're just going to repeat the same exact process over here. Okay, so here's our first point of the cycle. Here would be our last point of the cycle. Okay, halfway between these two minimum points, we're going to be up at a maximum. And halfway between any minimum and any maximum, we're going to be on the x-axis. Okay, and there's our second cosine curve. So the frequency is 2. We fit 2 of them between 0 and 2 pi. The amplitude is 1, so it reaches a height of 1 and goes down to -1. And since the period is pi, once we hit pi, we will have completed 1 cycle. And again, do not forget to label your equation. Okay, on the test, if you forget to label, that's unfortunately a point off, so let's not forget to label. Okay, so in number 41, our amplitude is 5, and our frequency is 1/2. And since the period is 2 pi divided by the frequency, okay, we all know at this point, right, that is equal to 4 pi. Or if we don't know that, that's okay. You can keep the numerator, change the division and multiplication, and flip that fraction and the denominator upside down. And then if you multiply across, you get 2 pi times 2, which is 4 pi, over 1, which is just 4 pi. Okay, so now let's number our x-axis and y-axis. Okay, now even though we have to graph this from -2 pi to +2 pi, I first just like to graph it from 0 to 2 pi, and then just kind of, figure out what to do on this side of the graph after I'm done with that. Okay, so since it's a sine curve, we know a sine curve is going to look like this. It goes up, down, and back up. Okay, it starts at the middle height, ends at the middle height, and halfway between those 2 points, it's at the middle height again. And then in between the first and third points, we are up at a maximum. And in between the third and 5th points, we are at a minimum. Okay, so let's think about what we have here. So it says the frequency equals 1/2. That means we're fitting half of the curve between 0 and 2 pi. So we're not fitting this whole curve between 0 and 2 pi. We are fitting half of the curve between 0 and 2 pi. So if this is where 0 is on the x-axis, 2 pi would be right here. So we're only going to see the first half of a sine curve between 0 and 2 pi. Okay, so the sine curve starts at the middle height, starts at the midline, starts at the x-axis. So I'm going to put a point at 0, 0. Okay? Now you could see the halfway point, right, where we're ending right here, is also at the same height as that first point I just graphed. So at 2 pi, right, I'm going to put another point on the x-axis. Now, halfway between these 2 points, we're going to be up at the maximum. Now, halfway between 0 and 2 pi would just be pi. So at pi, we're going to put a point all the way at the maximum. So halfway between 0 and 2 pi is pi. We're going to be up here at the maximum of 5. Okay, so this is what it looks like from 0 to 2 pi. It's the first half of a sine curve. Now, let's think about it. If we wanted to graph on this side, right, would we bump up again? Is that how a sine curve works? No, right? A sine curve, if this goes up and down, we'd have to keep going down before we come up, right? The sine curve keeps going and going and going, right? It's like a roller coaster, up and down and up and down. So from here, right, see on this side of the graph, I went over to pi and up to 5. When I get to this side of the graph, I'm going to go back to negative pi and down to negative 5, right? I'm going to do the exact opposite. That way, my curve flows and it continues. Okay, so then, since this is going to continue to come down to the minimum, once I hit negative 2 pi, I'll be back at a height of 0 again. Okay, and here is my curve. And again, make sure you label y equals 5 sine of 1/2 x. And you know, when it says right here that the period is 4 pi, what that means is it takes 4 pi units to complete one cycle. If you put this half together and this half together, technically that's one sine cycle. It's one full sine curve, okay? To go from negative 2 pi to 0 is 2 pi units. To go from 0 to 2 pi is another 2 pi units. So since 2 pi plus 2 pi is 4 pi, we could see from our picture, right, the period is how long it takes to complete one cycle. It did take 4 pi units to complete one cycle. Okay, number 42. So again, even though there's a negative in the equation, the amplitude is just the positive of what, the absolute value really, the positive of what's in front of the word sine or cosine. Okay, so that's going to be positive 2. The frequency, well, the number in front of the x is technically a 1, so our frequency is going to be 1. And since the period is equal to 2 pi over the frequency, 2 pi over 1 just simplifies to 2 pi. Okay, so now we know we're going to have to, on the y-axis, number up to 2 and down to negative 2. And here is how they want us to number the x-axis. Okay, if you wanted to space these out more, you definitely could have, okay? I didn't, but that's totally up to you. All right, so now, since we have a negative sine curve, okay, we know a negative sine curve goes down first, then up, and then back down, okay? So we have the first and last points on the x-axis as well as the middle point. And with a negative sine curve, halfway between your first and third point, we're at a minimum instead of a maximum. And halfway between your third and fifth point, we're at a maximum instead of a minimum, okay? So the negative tells us it goes in the other direction. Now, if the frequency is 1, it means that we're fitting one curve, one complete cycle between 0 and 2 pi. But we're not graphing to 2 pi, we're just graphing to pi. So if you were to fit one cycle between 0 and 2 pi, that means we're only going to fit half of our cycle between 0 and pi. So since we're only graphing to pi, we're only going to fit half of this cycle. We would need to graph all the way to 2 pi to fit this full cycle. Okay, so between 0 and pi, we are going to have just that, 3 points. Okay, so we could see this one, the first point that I see up here, as well as the third point that I see up here, are both on the midline, the x-axis. So at 0 and at pi, they're both going to be at a height of 0. And then halfway between those 2 points, right, halfway between these, we're going to be down at its minimum. So halfway between these, we're going to be down at the minimum, which is negative 2. So that is what it looks like from 0 to pi. Now, if you think about a sine curve, okay, I'm going to go up here. Sine curve would go down and up and down and up and down and up, and it would continue on and on and on, right? So if I start here and I work my way to the right, I'm going down and up. Wouldn't have to go up to a maximum before I come back down to the midline again, right? It's not gonna like bump back down again because that's not how a sine curve works. Okay, it continues the flow. So basically, on this side, since when I was at positive pi over 2, I went down to negative 2, over here, when I go back to negative pi over 2, I'm going to be up at positive 2. And then at negative pi, I'm going to be back down at a height of 0. So this is what it's going to look like. Okay, and then you can label y equals negative 2 sine of x. Okay, so we're on the last page here, number 43. All right, so we should be getting the hang of these now, right? So the amplitude is 1/2. The frequency is 4. And the period, since it's equal to 2 pi over the frequency, 2 pi over 4, would simplify to pi over 2. All right, so now if we want to think about what a cosine curve looks like, it starts off high, drops all the way down to its minimum, and ends back off high. Okay, here's our 1, 2, 3, 4, 5 points. Okay, now let me first just number the x and y axis. All right, so this is how I chose to number mine. You could number yours totally different. It's totally up to you. All right, so it says that the frequency is 4. That means between 0 and 2 pi. I have to fit 4 of these. So I have to fit 1, 2, 3, 4. Now, the period is basically telling us where is our cycle going to end? Where's our first cycle going to end? How long does it take to complete one cycle? It takes pi over 2 units. So once I reach pi over 2, I'm going to fit one full cycle in between 0 and pi over 2. So since the cosine curve starts off high and the cycle ends off high, what that means is at 0, I'm going to be at the high point, which is, the amplitude is 1/2, so it's going to be, the high point is up at 1/2. And then since pi over 2 is where our first cycle is going to end, at pi over 2, I'm also going to be up at a maximum of 1/2. Okay, now, halfway in between our two maximum points, right? So if you work your way into the middle, we're going to be all the way down at a minimum, which in this case is going to be at negative 1/2. So if I go halfway between these points, I'm going to be down at our minimum right here, which is negative 1/2. Okay, now this might be a little squished, but halfway between any maximum and any minimum, I'm going to be on the x-axis. Now, since there's only one box in between this maximum and this minimum, right? There's only one box in between them. I'm going to have to go halfway between them right there in order to be on the x-axis. Okay, and same thing right here. So this is my first cycle. It's small and squished in there, but there it is. So you're going to repeat this process again. Okay, the next cycle starts at pi over 2, 1/2, and ends at pi 1/2. Okay, there's my two maximum points. Halfway between these two maximum points, so if I work my way into the middle, I'm going to be down at the minimum, which is negative 1/2. Okay, now halfway between this maximum and this minimum, I'm going to be on the x-axis, and that occurs in the middle of the box because there's only one box between the maximum and the minimum. So in the middle of that box, I'm going to be cutting through the x-axis, okay? And same thing here. So this is what my second cycle looks like. Okay, since I'm graphing between 0 and 2 pi, all said and done, I should have 4 cycles on my paper. So here's the first 2, and I'm just going to keep going, okay? So here's the end of my next cycle, and then, here's where my minimum point goes, and then here's my 2 points on the x-axis. Okay, one more of those. Here's the end of the 4th cycle. The minimum is halfway between them, and then here's where my points on the x-axis go. So here is the graph of y equals 1/2 cosine of 4x. It has an amplitude of 1/2, and we're fitting 4 of these between 0 and 2 pi. All right, number 44. Okay, so even though we have a negative, we know the amplitude is positive 4. And we know the frequency is 1/2. And since the period equals 2 pi divided by the frequency, 2 pi divided by 1/2, at this point we know is 4 pi. If not, you could look at the work I did for other examples on that. All right, so now let's number the x-axis as well as the y-axis. All right, so I went from negative pi to positive 2 pi. That's a little different on the x-axis. And then the y-axis, I just went from negative 4 to positive 4 because my amplitude is 4. All right, so we're graphing a negative sine curve. The negative sine curve looks like this. Okay, so if we look here, right, the frequency is 1/2. It means if we were to have these 5 points, right, the first point, the fifth point, the third point, and then the second, and then the fourth, right, that's the order we graphed them in, we are only fitting half of this curve between 0 and 2 pi because the frequency is 1/2. So what I'm going to do is I'm going to erase the second half of this curve. So this is what we're going to have between 0 and 2 pi. Okay, so this is where 0 is, and this is where 2 pi is. And they're both on our midline, which is the x-axis. So at 0, we're going to be on the x-axis. And then at 2 pi, we're going to be on the x-axis again. Okay, again, because we're only seeing, since the frequency is 1/2, we're only seeing half of this between 0 and 2 pi. And then we know halfway between these 2 points, right, halfway between these 2 points, we're down at its minimum. So since the minimum is negative 4, right, we could see pi is halfway between 0 and 2 pi. So at pi, we're going to be down at negative 4. All right, so this is what we have from here to here. Now we have to go back to negative pi. Let's think about it. If this sine, if we start from the right, and we start going like this, we'd have to continue to go up, right, before we came back down. But we're not going to come back down because we're going to stop at negative pi, 4. Okay? Think about it. If when we went over to pi, if we went down to 4, let's do the opposite. If we go back to negative pi, wouldn't we go up to positive 4? And because they want us to stop graphing at negative pi, once you connect this, this is where our graph is going to end. So this is y equals negative 4 sine of 1/2 x. All right, and the very last one, number 45. So this one, the amplitude would be 3. The frequency would be 2, and the period is 2 pi over the frequency, so 2 pi over 2, which simplifies to pi. Okay, so I numbered my x and y axis. Now, you know, because we're only going from 0 to pi, I know some of you guys like to spread these out a little more. Instead of skipping 2 boxes between them, if you want to skip 4 boxes and make this pi over 2, and then 4 more boxes and make this pi, so it's not so squished together, you can totally do that. It's up to you. All right, so we're graphing cosine here. So cosine, we know, starts high, drops down, and ends high. Now, since the frequency is 2, it means if we were graphing to 2 pi, we would fit 2 curves. But we're not graphing to 2 pi, we're only graphing to pi. So if you could fit 2 curves between 0 and 2 pi, that means we can fit 1 curve between 0 and pi. So we're going to fit this whole curve between 0 and pi. Okay? So our cosine curve is starting high and ending high. Okay? So at 0, we're going to be at a maximum of 3. And at pi, we're going to be at a maximum of 3. Now, halfway in between these 2 maximum points, so if you work your way into the middle, we're going to drop all the way down to the minimum. So if you work your way into the middle of these, we're going to be all the way down at the minimum of negative 3. And then halfway between any maximum and minimum, we're going to be on the x-axis. So since from here to here, there's 2 boxes on the x-axis between them, half of 2 is 1. If you go 1 box, right, 1 box from the left or 1 box from the right, this is where we're going to be on the x-axis. And same thing right here. So this is what our curve looks like. And that's all we need for this one. So this one is y equals 3 cosine of 2x.